Hey there, fourth graders. Mr. Height, your science favorite or favorite scientist, however you want to say it. It's Friday. Been a long week. Anyway, welcome to the final piece of the lab. And if you were able to do the marshmallow madness, like you see all the marshmallows behind me, those are large. Hopefully your catapult didn't launch anything that big. It would probably break. Plus, you don't want to launch any marshmallows that are dipped in chocolate and have sprinkles because I actually want to eat those. I would not want to ruin those delicious marshmallows. Um, but you could go ahead and ruin the ones that you have, hopefully. So Marshmallow Madness, I actually launched some, and I want to find the speed. I want to see which of my 3 launches for Marshmallow Madness went the fastest. So do you remember the 2 things we need in order to recognize, identify, calculate speed? Hopefully you do. You'll need those. Make sure you measure accurately, centimeters and with a timer seconds. So there's an optional sheet that your teacher could give you, or you can do this in your science notebook. But I'm going to go ahead and share my screen so you can see what I'm looking at. There we go. So this is the recording sheet that you can use, and there's even an exit question at the end. We'll actually look at that question here at the end to kind of wrap everything up. So here are my launches, and you notice launch 1, I had a distance of 426 centimeters, and my time was 2 seconds. And I think it was like 2.1, but I went ahead and rounded to the nearest second. Launch 2, 520 centimeters, my time was 2 seconds. That's very interesting. So even just looking at these 2, without even calculating speed, can you identify which one was faster just by knowing these 2 numbers? Without even calculating the speed, can you tell which one was faster? And then my launch 3 here, a little interesting. Still okay, close to 400. It took a little longer, and what I noticed about this one is when I launched this one, it went higher. So it was almost like it went up a little bit higher. So it was stayed in the air a little longer, and it didn't go as far. So I'm wondering, does that make that faster or does that make that slower? What do you guys think? I don't know, but we can actually calculate that. And how we can do that is just remember speed equals distance over time, or you can say speed is distance divided by time. These are equations, math equations for finding the speed. And obviously you would have your units. In this case, it would be centimeters per second would be my unit, which that just means for every second, it's going to cover that many centimeters. So that tells you the speed, like miles per hour in a car. You know you're covering that distance within that time frame. So if I'm going 70 miles per hour in my car, I know that on average I am covering 70 miles for every hour. If I was going 50 miles per hour, obviously that's slower because I'm only going 50 miles in that same period of an hour. So that's a good reference there. Okay, so I can actually calculate my first speed there, which was 426 and 2 seconds. So you can set up a math problem for that one. If you're in division, you can totally do that. If you haven't really covered division yet by this time, you could use a calculator and put in 426, divide key, and hit 2. The cool thing about this one is you can do a little mental math here and know that you can divide and get 213. You can check that by multiplying 2 times 213 to see if I get 426, which I do. So launch 1, the speed was 213 centimeters per second. So that means for every second the projectile, my marshmallow, was going 213 centimeters. Cool. And for my next one, you can see that I have 520 centimeters divided by 2. So I can show you that we can set it up in multiple different ways. So speed would equal 520 divided by 2. I could set up as a fraction, or I can set it up as an equation here. Speed is 520 centimeters divided by 2 seconds. You could even put it in your form, 520. There's multiple different ways to do division, as you have been taught in class. So we could do something like this if we were doing the regular algorithm. So you would go ahead and check that. So if I multiply 260 times 2, do I get 520, back to 520? Cool. So check me on that, check my math. It's always good to check everybody's math, make sure we're good. Absolutely. So 260 centimeters per second. So is that faster than launch 1? Launch 1 was only 213 centimeters a second. Launch 2 was 260 centimeters a second. So obviously already we know that, that launch 2 definitely looks like it's a little bit faster than launch 1, 260 versus 213. And I already knew that because these two were the same time, and I noticed that it went further in the same amount of time. So obviously it had to have been a little bit faster. So far launch 2 looks like it's going to be my fastest time. So let's look at launch 3. And what do you predict for launch 3? Do you think that's going to be faster than launch 2? Or do you think that's going to be slower than launch 2? So again, we can set up a little division problem for that in many different ways. If you're not into this type of division yet, you can totally use a calculator. That will be your teacher's decision depending on where you are in division. So I'm going to go ahead and 369 divided by 3. Looks like we might have a little bit of a remainder here, which is fine. 0, 9, 3. Cool thing is I love math too. You know, all scientists also like math. If you're a scientist, you gotta love math too. It's just kind of a requirement. Boom. Oh, we don't. So it works out really nice. So just make sure that that equals our launch total of 396. So what I'm doing is always doing some checking. So I always want to check my math. It's always a good idea. Boom. Notice that that equals my original launch total. So I know my division is in good shape there. So that was what, 132? Wow, 132 centimeters per second. 132 centimeters per second for my speed of launch 3. And like I told you, I did notice, and that's a very cool thing, is make you record your data, but also record anything out of the ordinary that might happen. How did the launch go? Did it go straight? Did it go to the side, left or right? Did it go further up in the air? I noticed on this one, it went further up in the air like an arc. So it arced a little bit more than launch 2. Launch 2 went really straight. It didn't arc too much. It was definitely very fast. But I couldn't really tell between 1 and 2, which was the fastest until I actually did this. So launch 3 was definitely slower, the slowest out of all 3 of my launches. So right now I can tell which was my fastest. Hopefully you say launch 2, and I'll circle that, put a little star, happy face, whatever you need to do to identify your fastest launch. Then go ahead and see what everybody else is doing. Did they also do their launches? And share your data with the class, share it with the teacher, circle your best launch, and you can see who in the class had the fastest projectile, fastest marshmallow. Mine was 260 centimeters a second. Did anybody beat my speed of my marshmallow from my catapult? 260 centimeters a second. If you beat me, congratulations. You beat Mr. Height, your favorite scientist. I'll get you back though. Anyway, hopefully I had some fun with that. So cool, math and science together. Woohoo, who knew? Let's go down to our exit question here. And we have a cool little thing that goes right with what we were talking about. John Paul belongs to the science team at school. He wants to know the average speed when he launches a ball from a catapult. He makes the following list of information he could collect. So these are 4 pieces of information, data that he could collect. So A, the distance the ball travels. Could he collect data on that? Yeah. The total number of pieces of the catapult. He could count the pieces he needs for the catapult. C, the direction the ball travels. You could totally do the direction. And D, the time it takes the ball to travel. You could totally do that. So all 4 of these look like pieces of data that we could actually collect and we could write down. But here's the question: which items on the list does John Paul need to know to figure out speed? So we actually want to figure out, these are all nice pieces of data, but which 2 do we need in order to figure out speed? Is it A, B, C, or D? So what do you guys think? Go ahead and pause it here. Talk about it. Talk about it with your class or a peer. Cool. All right. What do you guys think? Do we need A for speed, the distance the ball travels? I think yes, we do need that, as we saw in our Marshmallow Madness fun we had. Oh, see, already messed up. I don't want to put a check yet because I need 2 things. So if I said A and B, I'm not too sure about that. So hold on. I know I need A. So I know I'm going to put a circle here. That's what I meant to do. I'm sorry. I know A is good. So I'm going to circle A as part 1. So what about B? The total number of pieces of the catapult. That's nice to know, but is B going to help us calculate speed, identify the speed? I agree. I don't think B is necessary. So I'm going to put an X on all my B's. Okay, so you can see what I'm doing here is a little strategy to help me eliminate some things. That's what I meant to do the first time, but you know, it's Friday, I said. Give me a break. All right. How about C, the direction the ball travels? Well, the direction the ball travels does indicate something. It's kind of like speed. Do you remember that word? It's speed plus something else, which is a direction. Do you remember that word? So if I add a direction to speed, I now have, hopefully you said, velocity. So that's velocity, which is nice, but it's not what we need to calculate or identify the actual speed of an object. So I'm going to cross out anything that has C. Yeah. All right. So now, as you can see there, definitely answer choice C is totally eliminated because I have two X's here. So bye-bye. So C is gone. Okay, I've eliminated both. All right, let's look at A. I have A, but I eliminated that choice B, so goodbye A. Okay. And, well, you could already tell D, it can't be D because I eliminated B, but let's look at D. The time it takes the ball to travel. So do we need time to calculate speed? Absolutely, we need time. We need distance and time. That was back at our formula, speed equals distance and time. So I'm going to circle D. Yes, we need that. So what is the correct answer then? Well, I've got two circles here on B. I've got an X and a circle. So bye-bye D. It's gotta be B, A and D, because A says distance the ball travels, D says the time it takes the ball to travel. Little test taking strategy there. If you have something where you need multiple pieces of information, this could help you eliminate some of those choices so you can identify the correct answer. A little test taking strategy to help you with your quiz or any other assessment you might have. Excellent. That was a lot of fun, wasn't it? I always have fun with science and math. And big marshmallows covered in chocolate. I have fun with that too. So I hope you enjoyed catapults, and I hope you understand a little bit more about speed and how to calculate it, especially the vocabulary words. Make sure you can identify the different vocabulary words with the concepts. So speed, acceleration, velocity, position, motion, all those different words you need to associate with these concepts. So good job, everybody. And Mr. Height here, I will see you next time.